All right, last one, and hopefully this upside down writing for the flip isn't too obnoxious. What we're looking at on this one is nomenclature of a bunch of different types of compounds, all mixed together. My tips for you, find them both on the periodic table. If you look for both, and there are more than both, you have a polyatomic ion that's going to need to be named. And once you find the elements on the periodic table, that's where you can make your plan. So I look for the first one, lithium and fluorine. Lithium's group 1, fluorine's group 17. It needs nothing fancy. Lithium fluoride, Fluoride. Next one, I go to look on the periodic table. I see a polyatomic ion with sulfate, but I also see hydrogen out in front. That means it'll be named as an acid. Sulfate makes it sulfuric acid. I know we learned rules for nomenclature of acids in packet 2. Sulfuric's one that we'll use a lot, and you should probably recognize, even if you're not top-notch on your naming of random acids. This is one that's good to know. K3PO4, too many capital letters. I got a polyatomic ion and a common one that would be good for you to know. I'm not going to have you memorizing piles and piles of random ones, but when you go to take the test on this, I'll give you a list of ones you need to know. I know that that's got to be it because that's just potassium. PO4 is phosphate. Potassium, phosphate. That's ugly in Spanish. Feo, that's ugly in Spanish. But for us, that's iron and oxygen. Find them on the periodic table. Iron's in the middle, it's going to need a Roman numeral. All right, what's its Roman numeral? Well, the charges have to be equal but opposite. So if oxygen is 2 minus, iron has to be 2 plus. Iron, 2, oxide. And if you love those Latin names, which I don't, you got to know a couple things. You got to know that the 2 plus is the lower charge of iron, that iron is Fer, F-E-R-R, and that the name that goes with the lower charge is OUS. So that would be ferrous oxide. But you got to know 3 separate things for that, where I just got to see that plus 2 cancels minus 2. To name it as iron 2 oxide, and I think this is why more people use this system. P2O5, those subscripts make me suspicious. When I find them on the periodic table, they're both nonmetals. So I'm going to use prefixes that represent those numbers, and remember the prefixes go on the same element. Diphosphorus, pent for 5, oxide. You don't have to do pentaoxide. Usually drop the A there. HBr starts with hydrogen, so it's an acid. What's up with this? Br, binary acid, needs the hydro thing. I always think of hydrochloric, but since it's bromine, this one's hydrobromic acid. Cool. Find magnesium, find sulfur. Group 2, group 16, nothing going on exciting there. Magnesium. Sulfur, just from the periodic table, is going to be sulfide. The ate and the ite, they have oxygen with them. Sulfate, SO4. Sulfite, SO3. Sulfide, just S. Same thing here. Calcium's group 2, nitrogen 15. We got calcium, nitride. Not nitrate, not nitrite, nitride, because I have no oxygens. On to the next. Let's write some formulas and balance some equations. I only have one equation up to balance because the rest are pretty straightforward. All right, barium hydroxide. Found barium group 2. It's a 2 plus charge. Hydroxide's one of my polyatomic ions. You might want to look for it on the periodic table because of the IDE ending. Usually the ions are ITE or ATE. So we've just got regular old hydroxide here. I'm going to need barium and hydroxide, but how many? I need the charges to be equal but opposite. So to cancel the plus 2 from barium, I need 2 of my 1 minus for hydroxide. Next one, really easy. As soon as I see this difluoride, I know I have 2 nonmetals. No, nothing with the first one, so it's just nitrogen. And 2 fluorines. Good. Iron 3 nitrate. That means that 3 is my charge on iron. Okay, cool. Nitrate, ATE, so polyatomic for sure, with a -1 charge. So I'm going to need 3 nitrates, NO3, to cancel the iron. Fe, NO3 in parentheses, make sure, 3. Potassium sulfide. IDE is right from the periodic table. Potassium's group 1, so 1 plus. Sulfide 16, so 2 minus. We need the charges equal but opposite, so I need 2 potassiums, 2 times 1 is 2, to cancel my -2 from sulfide. I used something a little different in the next one to show you what's up here. Calcium's +2, but this is sulfate. From my ion sheet, it's also -2, but it's going to be SO4. Calcium's +2, sulfate's -2, just CaSO4, calcium sulfate. Carbonic acid. It's an acid, so it's going to start with hydrogen. And hydrogen has a 1+, try to write it a little bit bigger there, a 1+ charge. Carbonic, the IC, says I'm using the carbonate ion, which is CO3 with a 2- charge. So that's basically carbonic acid. I just need to balance my charges. 1 times 2 cancels out the 2- charge. Good. Phosphorus 5 chloride. I know it's 2 nonmetals, and that's fine. Whenever I have a Roman numeral, that charge goes to the first one. Chlorine is -1. I need 5 chlorines with 1 phosphorus, PCl5. Wait for Lewis structures. We draw that all the time. That's like one of the top Lewis structures we will draw too many times. Sodium hydrogen carbonate. Hydrogen carbonate's funky. That's something going down. That's a polyatomic ion. It's not just carbonate, it's hydrogen carbonate. You'll also see this called bicarbonate. If you look it up on an ion sheet, you've got it, and it's got a 1- charge. So sodium also, +1 charge. Na. You can also do hydrogen carbonate from those 2 names, but if you look it up, it's safer. You know how many hydrogens you need. HCO3, a Hollister ion. It's baking soda. NaHCO3. Dinitrogen monoxide, I see prefixes, so N2O. Di is 2, mono is 1. Aluminum oxide, straight from my periodic table. 3 and 2, Al2O3. That's a 2, and we good. Let's balance and classify some equations. When I classify equations, I'm looking for a couple patterns, and we're going to see them in the examples. Synthesis, 2 things make 1 thing. Decomposition, 1 thing makes a bunch of things. Single replacement, an element and a compound on each side, and the element throws something out of the compound. Double replacement is 2 compounds and things switch places. Combustion, it's usually a hydrocarbon, but you can also have oxygen with the hydrocarbon, like C something, H something, O something, for it to be combustion. It combines with oxygen and releases CO2 and H2O. So let's look at the examples. I'm only going to balance the one up here, and I'm going to do that one last, but I'm going to go through the examples we have quickly too. N2 plus 3H2 yields 2NH3. That's a synthesis reaction because I made 1 thing out of 2. S8 plus 12O2 yields 8SO3, also synthesis, made 1 thing out of 2. This next one was ugly. It's closest to double replacement, but the replacement's kind of like off. SiCl4 plus 4H2O yields H4SiO4 plus 4HCl. Fourth one down is a beautiful example of single replacement. Look on the left, bromines in, chlorines out. On the right, chlorines in and bromines out. 2KBr plus Cl2 yields 2KCl plus Br2, single replacement. Next one's a nice double replacement, but you sort of have to look at water in a different way to write it. You can also write water, which is H2O. You can think of it as H and OH, because I haven't done anything different by writing it that way. If you look at it that way, this is a pretty double replacement. 2AlOH3 plus 3H2SO4 yields Al2SO4 3 plus 6H2O. Hydroxides with aluminum on the left, hydroxides with hydrogen on the right. Sulfate is with hydrogen on the left, sulfates with aluminum on the right. They switched. Double replacement. I'm making stuff from stuff. This next one, synthesis, 4Fe plus 3O2 yields 2 Fe2O3. Skip that carbon one for right now. 2H2O plus 2H2 yields O2. H2O broke down, decomposition. Zn plus 2 HCl yields ZnCl2 plus H2. It's single replacement. Zinc replaced hydrogen in the compound. Now this next one is combustion. And I got this up here, right at the bottom, probably where you can see it. And I wrote it there for you. I want to balance this one, and it is, like I said, combustion. The way I usually balance them. 7 carbons, so 7 carbons. 6 hydrogens, so 3 times 2 gave me the 6 hydrogens I need. How many oxygens do I have? I have 14 oxygens from here, 7 times 2, and 3 oxygens from there for 17 oxygens. Okay, cool. Now, if I want 17 oxygens over here, I'm going to take off those 2 and have 15 left that I need. Being that I have to multiply by 2, that's kind of yucky, I'm going to do the cheater way. I shouldn't say cheater, the easy way. Use a coefficient of 15 halves, or 7.5. I can do that. If I hate that, I don't have to do that. This is how I would balance it. Figure out carbons, hydrogens, calculate my number of oxygens. In this case, I had to correct for that, but it gives me the coefficient on O2. Now, if I get to here and I hate it, I gotta do a little creative here. I can put in a 2 there. And that will get rid of my 15 halves. Because watch this. If I put a 2 out in front, and I almost have to know, I almost have to try and get a half. I don't like to do this. Now I have 14 carbons. I would need 12 hydrogens, and 28 plus 6 gives me 34 oxygens. 2 of them are here. 2 times 2 is 4. So 34 minus those 4 give me 30 for 15. Exactly doubling the coefficients from last time. I'm cool with a half. It's fine. You can be, or you can correct it. Up to you. That's the end of your summer review, and I'll see you in school in the fall.